Hello, and welcome to Strategies and Discussion Model for Item Analysis, the first of 3 webcasts in the series, Mathematics, a look at the OGT. It's designed to support high school mathematics teachers who want to use Ohio graduation test results to improve student learning. My name is Peggy Costin, and I'm the Executive Director of the Ohio Resource Center for Mathematics, Science, and Reading. For those of you who are viewing live, you can participate in today's discussion by emailing your questions using the Submit a Question button. We'll answer as many of them as we can at the end of the live program. You'll also find support materials related to today's topic, including a webcast companion document, visualization, vocabulary, and implications, a handout of the OGT items to be discussed, and some other materials that will enhance the webcast experience. These items can be accessed at any point without disrupting the webcast. This webcast is predicated on the idea that the very best professional development is thoughtful conversation among and between faculty members as they consider the teaching and learning of mathematics. This webcast is not intended to provide silver bullets or even a prescriptive how-to method for preparing students for the OGT. Rather, it illustrates professional dialogue about student performance and provides some written materials that you may find helpful to stimulate dialogue in your own school or district using your own data. We will use state data to examine specific difficulties on some geometry items, suggest some interventions for those difficulties, and then acquaint or reacquaint you with some of the OGT resources available on the Ohio Department of Education's website. Today's panelists are Jim Wright. Jim is Assistant Director for Mathematics at the Ohio Department of Education. Jim was a high school mathematics teacher for 31 years before joining the department. Kay Wallace, who taught high school mathematics for 30 years and is now the mathematics supervisor for Pickerington City Schools. And finally, Carl Jones. Carl taught high school mathematics for 20 years and has been a mathematics curriculum consultant for the Darke County Educational Service Center for 10 years. Our panel is very knowledgeable about the OGT, but more importantly, they have all thought deeply about the kind of curriculum and instruction that will assure that all students learn rigorous, important mathematics, and as a byproduct, will easily succeed on the OGT. Jim, Kay, and Carl, welcome.
Thank you.
Thank you.
I believe that looking at how students answer specific questions can tell us a lot about how we should modify instruction. For example, today we will look at student responses around some basic geometry items. In 2004, there was an interesting item on the test. Carl, could you walk us through this item?
It says Daniel cut a corner off a cube as shown in the diagram below. Points A, B, and C are the midpoints of the edges of the cube. What type of three-dimensional figure has been cut off?
Carl, this seems like a pretty straightforward, even easy item. Why do you think that fewer than 60%, 58% to be exact, of the students selected the correct answer? And what concepts and ideas would you emphasize for your students next year?
Peggy, let me take a second and talk about just the percentages on the data analysis, first of all. If the viewers notice that we had 3 and 4% answer A and B, which are not that logical of question or an answer anyway. So 7% were probably just landing on A and B by random guessing. Sometimes teachers forget that probably another 70% could have very well have landed on C and D just by random guessing. So the chances are that it's probably more likely that only 54 or 55% really knew the right answer of a triangular pyramid. The thing that draws them to C and D, I feel, is that the fact that they both have the word triangular in them. And so that's going to draw them to those two. But then what is discerning is that essentially about only 20% actually knew the difference between a prism and a pyramid. So this could be a vocabulary issue between the two words. And I guess what also makes this discerning is that the ability to identify between a prism and a pyramid is supposed to be a second and third grade indicator. And quite honestly, they may have very well have known that fact at that time, but maybe never reviewed this important information as it's gone along. So again, being able to look at this figure and visualize that part that's missing and knowing the definition difference between a prism and a pyramid, I think were some of the essential difficulties that students had with this problem.
Jim, do you have any additional thoughts about why students struggle with this particular seemingly obvious item, or are there any instructional implications?
Well, I'd agree with what Carl's had to say. I think also that the use of precise language, the language of prism and pyramid for some students is difficult. You know, sometimes we tend to not use that language every day in class. The idea of the visualization of three-dimensional objects in a two-dimensional drawing is very difficult for students, and that visualization I think also adds to it. So I think those 2 points, the language and the visualization, are two critical pieces.
Kay, would you like to add anything to this?
Well, I think that you would have to break this question apart into steps for students to really get to the bottom of why they chose the wrong answer. So I might begin with just pictures of what the corner that was sliced off might look like to see if they really can't visualize that corner or if they don't know the words to describe it. So you don't know which it is initially. And then I would also add that even at the high school level, you need to start with some 3D models and give students experiences with cross sections, what the pieces look like after you've sliced them, what the cross section looks like, leading into those higher grades, which would include conic sections and calculus and those kind of higher level thinking. They need to get those concepts at this point.
You've all kind of mentioned visualization, and that seems to be something that should be natural for kids, don't you think? Or do you think visualization is something that we really have to work on in the high school mathematics curriculum?
Visualization is an important part of it, and it's a part we ignore. Take the fact of manipulatives. They sometimes have a very negative connotation because we think that the only students that need manipulatives are those that are challenged, don't understand it, or maybe it's just the elementary students. And thinking that just because they're in middle school or high school that they no longer need or can benefit from the use of manipulatives. Kay's already given examples with conic sections and stuff, which is higher level high school mathematics, where manipulatives can still be a very powerful teaching tool, and I don't think we utilize it enough.
And I also think we make the assumption that all students can look at a 2D drawing and picture that as the 3D object it is, and they can't. Many can't do that. Surprisingly, many cannot do that.
Is that something that students get explicit instruction on? It's been a long time since I taught geometry, but when I did, I was amazed to find that students could not sketch 3D objects. And we actually spent some time on that in the geometry curriculum. Is that typical, or is that not typical now? Are teachers doing that in geometry?
I think they probably are some. I don't think it's universal. You know, getting back to Carl's points on manipulatives and so forth, you know, some use it, some don't. I think one of the points that this leads to is the idea of the differentiation of instruction for different students. I mean, you know, we still had 58% get it right, so 54% of the students, maybe they've had good instruction. Maybe they knew that, and that is something that worked for them, but that's leaving an awfully big number of 45% that maybe we need to be looking at alternative ways. You know, are we providing enough different pathways into problems for students, as opposed to assuming that all students understand it in a very logical, algorithmic way, or, you know, straightforward way, and have the visualization. So, you know, as we've talked before, you know, this is a case where maybe you're talking about trying to bring in the ability to draw and visualize, and maybe that's some place where the art teacher can actually help a math teacher, and some places where we can talk across curriculum. So.
And to get to those alternative ways, don't forget to ask students, how did you come up with this answer? How did you solve this problem? And you can hear several different ways of getting to the answer.
Unfortunately, we need to move on a little. The same percent, 58% of the students, responded correctly to this next item from the 2007 OGT. This also included ideas around prisms and pyramids. Jim, will you take the lead on this problem and kind of walk us through?
Okay, there's a figure there, and it says the figure shows a three-dimensional object when viewed from above, and then they give you the diagram or the object, and which of these objects could the sketch represent?
Do the data surprise you when you look at these data and that item?
Well, I think the thing that may be the biggest surprise is the close similarity to the item we just looked at from 2004 and Carl's interpretation there. That, instead of 3 or 4%, we now have 5% that guessed A, 5% that guessed B, and both of those seem to be not realistic items, because if you look at the figure, what you see there is a square, and you see the triangles inside, which would lead you to that 90% that guessed either or stated it was either C or D. The base and 58%, and so if we use Carl's same logic and reasoning, we're about 52, 53% that knew that item. And I think the D was a very obvious wrong answer because of the 4 triangles they see in there. So you're going directly to the triangular. Again, trying to take that 2-dimensional object and visualize it as a 3-dimension is a difficult skill for some students.
Carl, as Jim remarked, these data are very similar to the data on the first item. What's your reaction to that?
Well, and I think teachers need to realize that even though these problems are different, they're assessing the same concept. Can the student visualize something that is only very abstractly shown, and do they know the difference between a prism and a pyramid? In working with assessments, they have to understand that to know if a student actually understands the topic, they have to be able to take that understanding that they've learned on one problem, be able to look at another problem that they have not experienced it before, and apply that concept in this new situation. If they can do that, they truly understand the concept. If they can't do that, they probably just memorized a situation instead of being able to apply the concept. So teachers need to look at ways to ask different questions, and instead of trying to test prep by memorizing all these problems, you need to prepare for a test by teaching a deep understanding of the concept. If they know the concept, they'll be able to solve any problem that involves the concept.
I think few of us would disagree with that, but Kay, do you know of effective ways to help students internalize these definitions and concepts that Carl was just talking about, and so they can apply these and correctly answer the OGT questions?
Well, to get to the difference between prism and pyramids on both of these, I think that would start in lower grades, where you might do a sorting activity of models with the vocabulary words, or you might do a sort of 2D drawings with the vocabulary words, or you might do a sort with 2D to 3D models. All that needs to occur before we even get to this level where you're putting this all together. But in addition to that, if you start with some models that are 3D, like this one, and have students draw that from different perspectives, and we're kind of talking about architectural drawings or something. So what does this look like from the right side and the left side and the back side, and have them draw what that looks like from the top? Then that gives them some of those experiences, so that when they do see a figure like this they haven't seen before, they can picture what that really would look like a little more easily.
You guys have talked about the importance of visualization. You've talked about sorting and vocabulary, and you've given some very specific kinds of possibilities for instruction related to all of those things. I guess I'm interested in how should a mathematics department look at making decisions about adjusting their instruction. I mean, this is fun and this is good, and I'm with you, but realistically, how does a mathematics department take this kind of discussion into action, and how do they really change their instruction to have this emphasis on visualization and manipulatives and vocabulary and sorts and all the kinds of things that you're talking about? Or do you believe that's already happening?
Well, in the time I've been with ODE and working with some schools around the state, I think one of the big issues that comes up is the idea of that vertical articulation, of being able to know how within your curriculum, K-12, whether it's, we've heard some of these things are 3rd and 4th grade. We've heard some of these 5th, 6th grade. We've heard at high school. When a topic keeps reappearing, how does that instruction, how does that depth of knowledge grow for the student? And I'm not sure that from my experience in 30 years in the classroom, that I really understood that. I knew what my piece was or how I instructed it at high school, but I'm not sure that we had the discussions of how did that start and how do they grow that at 5th grade, at 6th grade, and if we've got those same topics out there, are they seeing the same type of instruction all 4 years? In which case, instead of the topic growing for students, it probably frustrates them, because those that understood it continue to understand it, and those that didn't are just more convinced that they don't understand it. So I think it's really important for staffs and for people to really see how their piece of it and how this topic and the mathematics grows for students.
I think another thing that goes with this, if you're talking about a math department trying to change what they're doing to improve, is they have to do the same thing that they're promoting their students to do, and that is to problem solve. They need to look at this data and they need to look at patterns. They need to see what kind of patterns are emerging there. Is it visualization? Is that an issue across our instructional pattern? Or is it something else? Is it vocabulary? Is that a major issue that's happening in all these things? And so if they start looking at these patterns. And then the second thing is that what Kay brought up is to ask the students. So many times we forget to do the formative assessment thing. You say, why did we miss this one? Because kids will tell you, what part was missing for them.
So part of that rich discussion that staffs can have would be around assessments that they could create or discuss. They could discuss with each other, why did your students do better on this than mine? What do you do in the classroom? Collaborate with, brainstorm good ideas for those difficult areas that their students are not responding well on. And then go out and look outside of the school for other resources, for lessons, activities, different ways they might approach those difficult areas.
We are going to move on now to a third item, a different kind of item. We're still assessing geometry. It appeared on the 2005 OGT, and the students did very poorly. Kay, will you start the discussion on this item?
The item reads, Joseph plans to tile his kitchen floor. All the tiles will be identical regular polygons. Joseph wants 3 tiles to meet at each vertex with no space left over. What shape of tile should he use?
Kay, are you surprised that only 26% of the students got this answer right?
I'm not surprised, because there is no diagram or anything to start students on to think about the problem. So they have to create what this might look like in their head. And if they have not had any experience with tiling, then they might not even know how to begin the problem. They might not even be able to start at all. And it looks like kind of the results were across the board, so you might guess that. I do know, in my experience over the years, tiling is not a topic that is generally discussed unless a teacher on their own just kind of decides to bring that on. But it doesn't surprise me in that I don't think students would know how to begin to do the problem.
Carl, what do you think was so difficult about that item?
Well, Peggy, I think this is where sometimes teachers can get too focused on a particular indicator. I think the benchmark that's being measured here is benchmark A that says formally defined geometric figures. And the indicator is actually at even a lower level, which is talking about interior angles, what they're assessing here. But if you just teach interior angles and you don't see a bigger picture, for example, as Kay was mentioning, tiling or tessellations, that topic, even though it's not mentioned in the standards at all, And sometimes teachers figure if it isn't mentioned in the standards, I'm not going to teach it. But they're missing the much bigger idea of what tessellations can do to teach the properties of polygons and to teach the properties of interior angles and to just how polygons fit together. So here's a case where if you focus on just what's in the standards, i.e. tessellations not being there, I think you miss a powerful teaching tool that I think anybody with tessellation experience would have solved this problem easily.
Jim, do you have any hints or suggestions on instructional strategies for this particular item?
Well, I think one of the things is that, using some concrete examples, I go back to examples that a lot of people use when they're teaching triangles, and some of the angles add up to 180, and you take a triangle and you tear it apart, and you put the three angles together and see it's a straight line, something along those lines, something that's concrete for kids. But I think one of the other issues that came up here was the fact that, if you look at those answers and the way they split up, I'm a little amazed or a little surprised to see the main answer was triangles. Triangles was more than squares and the others. If you think about tiling, students are familiar with square tiles, and they know that those are going to work. Triangles will work too, but I think one of the keys is it says 3. It says they have to have 3 points. So as soon as they see 3, some students are taught some test-taking strategies as opposed to true mathematics, and they see a word 3, so they go to triangles. So reading the problem carefully and knowing what's going to, what you're really looking for, because you could do a pattern with the triangles, with a square, with a hexagon, but it said you could only use three of those tiles. So I think they misused and misrepresented that 3 there, and that's would be my guess on that. But still 86% or so guessed one of those 3, and those could all be used. But it didn't fit the second half of the problem, which said you can only use 3 tiles at that point.
And I would like to add this will be a perfect time to bring in pattern blocks even at the high school level. We don't see those in the high school classrooms, but throw out pattern blocks and say, what can you make? How many would fit together and have no space left in different cases, and have them prove it by the angle measurement, etc. So I think pattern blocks will come in here very nicely.
So do I. We need to move along, and the final item we'll talk about in today's webcast is a constructed response item, and students did not do well. Jim, will you lead us through this item?
The item reads, the diagram below shows 2 of the faces of a prism. Ellen is constructing this triangular prism out of cardboard. Ellen plans to draw a shape, a net of the prism, on a piece of cardboard that she can cut out and fold to make the prism. In your answer document, sketch a net of the prism that Ellen could use. Place the dimensions on the net.
If you look at the data on this particular item, kind of amazingly, 67% of the students either did not respond at all or received a score of 0. So fewer than 1/3 of the students got any kind of points at all on this item. Now, it could be argued that students do not routinely draw nets, but a quick perusal of the academic content standards suggests that students should have familiarity with those ideas beginning in the middle school. And some of the results from the Ohio Achievement Test would suggest that students do have familiarity with ideas around nets. If you look at the grade level indicators, we can see that both in 5th grade and 8th grade there are very explicit indicators around nets. And then if we further look at some assessment items from the OAT from the 5th grade, which figure shows the net for a rectangular prism, and then we look at the data, 56% of the 5th graders got that right. That's really pretty good. A second item on the 5th grade test, a net of a 3D shape is shown. Which 3-dimensional shape? 71% of the kids got that right. That's wonderful. Let's go to an 8th grade item. This is a more difficult item and is actually more like the item on the OGT. Ray found the paper cutout shown. Which 3-dimensional object is formed when the cutout is assembled? And then in this multiple choice item, 86% of the 8th graders correctly said cone. So, I guess Kay, do you believe the difficulty was not knowing what a net was? Let's talk about the difficulty on this particular item and why did kids perform so abysmally?
Well, I think they do get a lot of experience in lower grades with nets, and I do think they know what a net is. But this particular item would require that they draw all the other faces of this prism. That's kind of hard to visualize. That's hard for students to come up with the dimensions or even the shape of the other faces just by looking at the two faces that were given. So I think that's the difficulty. It doesn't look like a net yet. You've got pieces that have to be put together, and they have to come up with those other faces. I think that's what makes it hard.
The other thing that is added on to this is measurement. You know, this is none of the other items had measurement included. Now suddenly there's measurement included on this one, and the students are required to label the correct measurements on their response. And then of course you have the whole issue about students wanting to skip a constructed response item and just not being willing to attack it. So a lot of things work together against the student in this particular item.
And I would think, you know, looking at that data, unfortunately, it's like Carl sort of alluded to, is the fact that it's not that unusual on some of our constructed response to see a 60-70% of zero or did not attempt type response. That students, whether they have experience with constructed response items, whether they want to think through it. But I think, you know, the three examples you gave at the lower grades were all multiple choice. It was a case of taking something and pairing it and matching it to something that was there, whether it was a word was there or whether the net was there. Here, as Kay has alluded to, it's a case of where you're taking two of the shapes that form that net and they're having to do a lot more. It is a constructed response, so a lot of that comes into play. I also am not sure at the high school level if these students have gone through 9th and 10th grade in a formal geometry class, how often they talk about nets in a geometry class. You know, at that stage, we're concerned more about constructions. We're, you know, with some of even some of the software programs and things that are out there. It's a case where students' exposure to nets tend to be, I think, at middle school and so forth. So I think those all come into play. But, you know, just from our own experience and looking at data, I think that the type of question, whether it's short answer, constructed response, or multiple choice, has a lot to play with.
The other thing that, again, going back to what I said before, this is an unusual item. Typically, you'll not see this in a textbook. And I think this is why the content knowledge of the mathematics teacher is so important. Because if the mathematics teacher has the content knowledge behind this, they can start to ask questions at a higher level. They said, sure, you covered nets like this in the 6th and the 7th grade or wherever. Now let's ask a more complicated question. And then they can keep ratcheting up. Instead of covering the same topic at the same level, we were talking earlier, Jim, they need to keep making it more sophisticated. And I think this problem gets at that higher sophistication for nets in particular.
Again, I love this conversation, so I hate to move on, but I think Jim made a point about vertical articulation and how important that was, and I think this is a clear example where looking at some of the OAT items would be very useful for math faculties at high schools. And so, in addition to doing the kind of look at item analysis that we've done today, the Ohio Department of Education also makes a variety of materials available. Jim, would you share with us a brief look at what is available and where our viewers can find the materials?
On the ODE website, we do have the IMS, and on the IMS there are OGT questions. Those questions are annotated and they can be searched by standard, benchmark, year of administration, and keyword. The assessment web pages, which are also on the ODE website, will contain information such as test blueprints, formula sheets, released items, and things of that nature, answers keys, full and half-length practice test, along with statistical summaries. There's a third page now, which is the success website, and there's some training going on around the states. I know that the pattern's been to invite, I think, curriculum coordinators and then for them to take the information back, but it releases, and it was originally written with maybe the annotations are more in a parent-friendly or non-mathematical type language somewhat, but it can be used to generate practice tests. They are constantly adding to that, and you know, Kay and Carl may be able to add there. Also, with the handouts on the web page, there is a list of where on the web, some URLs of places where you can go to find some additional materials.
I think Jim gave you guys an opening. Carl and Kay, would you share with us some of the ways that you use some of the ODE materials?
Well, I use a lot of the released items. In the IMS, I go to released items. I've also looked at annotated items and shared those with teachers when I meet with teachers in groups. I have most often gone to that site, and with your access number code, you can get on and see item analysis, like what we're looking at right now for the state. You get your own district and item analysis and building item analysis. And it's even going to come to a point where teachers can do that for their group, and that way you can compare that to another building or the state's data, and that's been very helpful. In addition, when we sit down and look at item analysis and we see a area of difficulty, then we're always going to the IMS or sometimes to ORC and looking for a lesson or activity that would better help students understand that concept.
A couple of the things I really like about the Success webpage, and I probably think this is probably one of the most underutilized websites. It's actually just gotten up and running by the testing company, AIR. But a couple of the things that you can do. One is there's a very good examples and models of teaching teachers, and for that matter, teaching students how to do constructed response items. There's constructed response items there. They can look at them. They can see what it takes to get a 4, a 3, a 2, etc. They show you the rubric. And then they even go through exercises where you get to score your own and kind of see how you're doing. The more familiar teachers are, and for that matter, the more familiar students are being able to do that, I think the more successful they'll be in constructed response. The second thing that I really like on the Success webpage is the ability to regroup students. As when they take the test, they put them in the groups of however they're reported on the testing company. But a teacher can go in there and regroup a students. They can look at a group of special education students. They can look at a group of gifted students. They can look at a group that's in a whatever other subset that they want to look at, and then kind of organize their data in that particular group. And that allows them, again, to look for patterns about what their strengths and weaknesses might be.
Let me first of all say that we are receiving a couple of questions, and so I don't want our time to run out without taking the questions. The first question is, you mentioned pattern blocks and cubes. What other types of instructional materials could help develop visualization and other geometric concepts and skills?
Well, the first that comes to my mind is just a lot of, not just one class set of 3D models for students to look at. There are also the models that have the nets inside that you can pull out and lay out for students to look at. That might be at a lower grade. But just a lot of those, and they don't necessarily, we only always look at one view, maybe some that are oblique even. That's the first thing that comes to mind.
The other thing, and again, I work with schools a lot of times that are strapped financially, and you can't afford, we can't afford to buy those. The National Library of Virtual Manipulatives. If you've not been to that site, it's a must. You can Google it because we don't have the address.
It's on ORC too,
yes.
So you can search it on ORC. National Library of Virtual Manipulatives on ORC.
And what this allows is lots of applets, and you can get on there and you can see some of these three-dimensional. It's not as good as having the real thing there to touch and feel and move, but it's a very good substitute and can work. So there's always ways to work around this.
What about geoboards, isometric graph paper? Some of those kinds of things too.
Absolutely.
Right.
Anything? Let me go to this next question because I really think this is of some significance. Some of our students do not take a geometry course in 10th grade. What are some strategies that we can use to incorporate geometry into other courses? That's a real problem because geometry is covered on the OGT. So how would you answer that?
So I suppose the assumption would be they've had 2 years of algebra type courses. I mean, anything beyond that you could work into a pre-algebra course, something that was leading into the algebra very easily. I mean, that can include a lot of geometry topics. Actually, we've been dealing with this recently in our 8th grade, because they take an 8th grade OAT and they're in algebra, the students that are in Algebra 1, we've been working very hard to try to filter some of those geometry concepts into the algebra curriculum without altering it very much. And it's a challenge.
That's where I think, looking at curriculum is a must. You've got to take the standards book, but you got to look at what your actual curriculum is and how things flow. What's the pattern, not just at 7, 8, or 9, but what's 5, 6, 7, 8. What do those students' experiences have? And as you're looking at those things, we're the only country in the world that's still arguing about keeping algebra and geometry separate. It's a case that, or one of the few countries in the world. I know that Dr. Brad Pindell, who is our new Math Initiatives Director, comes from Georgia, and they have a set of integrated standards down there. And I mean, we'll get questions all the time, do we have any integrated lessons, meaning do we have science math lessons? And we'll say, well, there are a lot of people that are having trouble integrating algebra and geometry. So, what the key is that these are not separate math topics, and we really need to try to build to where the geometry supports the algebra supports the geometry, there's data. We have to quit looking at these as separate silos and not connected. We have to put the coherence back to the curriculum.
Another question. You have talked about visualization. What other areas of geometry do students have difficulty with?
Well, one of the areas that we don't test formally on, but we do, it is part of the test or assessment and standards, is the idea of proof. We don't do 2-column direct proofs and those kinds of things on the OGT, but students are asked frequently to support their work, to justify steps, to provide reasons for things happening, and one of the areas that sometimes gets overlooked is that formal logic or type of proof tends to be thought of that's only in geometry. We don't think about supporting those kinds of things in the algebras and so forth. So that's an area where they, just the formalization of that.
Anybody have anything to add to that?
No, I really think the visualization, I think 3D is where students have the most difficulty. Obviously, that's why we picked some of these problems, but the 2D geometry that I think of with polygons and all the characteristics of different polygons seems to be quite a bit easier for students than visualization.
And again, it's, when I, many years ago, had geometry, it was memorizing. It was memorizing definitions, it was memorizing theorems and corollaries, etc. And it was not making sense of geometry. Teachers, and again, sometimes they're limited by resources, but with the dynamic geometry software like Cabri and Sketchpad and others, to me it's almost essential to have some of those things to be able to manipulate the geometry and to discover this thing and make sense of it in their own sense, instead of just writing down definitions.
I'd like to apologize to those of you who we did not have an opportunity to answer your questions, but I need to close off today. And so I guess in closing, I would ask our panelists, do you have one point, maybe two, that you hope teachers will discuss after viewing this webcast?
I would hope that it would generate some discussions at schools on the vertical articulation piece of how topics are growing. And referring back to Dr. Fendel again for just a moment, one of his favorite things in teaching his classes or in the presentations I've seen him give is to take a math staff, pick out a math topic and say, okay, give me as many different ways to explain this as possible. Give me 3 ways to explain division by 0. Give me 3 ways, because we need that within our math arsenal as we teach alternative ways to approach it for students. Because if we only have one approach or even 2 approaches for students, we may not be able to help all those students to enter into the mathematics. And we have to believe that all students can learn significant mathematics.
Well, I would hope that we've made the point of models for visualization. Get out those 3D models and put them in the hands of students if possible, or at least go to a virtual model and help them with their visualization, have more experience with that.
The other point I think we've talked about is vocabulary. The language arts people know that vocabulary is essential, and they have lots of strategies for building vocabulary. And if you don't know how to work with that, talk to your language arts teacher about it, and because they have lots of strategies. I've developed lists for the different vocabulary lists. There's no official list for vocabulary, but it's not hard to go through the standards book and say, these are the words that they need to know, because the words that are in that standards document are the words that you're expected to be using in class on a regular basis so that kids are familiar with them.
Today we considered some statewide results for released geometry items from the OGT across 4 years. You may wish to see how your students performed on these items by reviewing your district's item analysis reports, or give these 4 items to your students using the materials provided as a part of this webcast. You have an advantage that the panelists did not. You can talk to the students about their responses, and this should help you know how to adjust instruction. Thank you, Jim, Kay, and Carl, for participating in this program and sharing your expertise with other mathematics educators in the state.
You're welcome.
Thank you, Peggy.
And thank you for your participation. In this webcast, we've discussed how looking at the OGT item analysis data can tell us not only what students cannot do, but maybe why they can't do it. We examined some specific geometry items and suggested some curricular and instructional changes to assure that every student is successful on the OGT. We've just scratched the surface of these topics. There are additional supporting materials on the website. We will be having 2 more webcasts. We hope that you would participate, and if you would like to learn more about